I warmly welcome you to Mittweida, to University of Applied Sciences, here in our studio, and also the viewers in our live stream, to the finals of the first STEM contest of the European University Alliance of Responsible Consumption and Production. So, what exactly does STEM mean? STEM is a common abbreviation for closely connected areas of study: science, technology, engineering, and mathematics. And EURECA-PRO is an alliance of 8 higher education institutions from 7 European countries that have set for themselves the task of inspiring young learners in these fields and sponsoring them. One of these universities is Mittweida, the University of Applied Sciences. Annabel Heimer from the International Office will now introduce it in more detail. So, applause for Annabel.
Hello everyone, my name is Annabel Heimer and I'm the project collaborator for EURECA-PRO of the University of Mittweida, and I'm working especially in the international office of our university, supporting the students with their regards. Thank you for having me today. So, I have the honor to introduce our university, which has a long history. It is more than 150 years old, and it is, used to be a technical college which developed into a University of Applied Sciences. It has more than 70,000 students at 5 faculties, and about 23% of them are international students. We have 53 study programs in bachelor, master, and diploma programs. We have more than 108 professors and 398 staff members at our university, and we have a combination of traditions and modernity and a strong hands-on project orientation. Our university is a place of ideas and innovation, and we paved the way for 75,000 students, and some of them became actually very famous. Here I brought some examples of our famous graduates. One of them was Walter Bruch, and he invented the color system of the TV. Another one is Gerhard Neumann, an engineer in aircraft construction, and he invented, for example, the turbines of an aircraft. And also he was a vice president of General Electric for 16 years. A third one, to close the examples, we have many more by the way, is Hans Balsen, and he was technical director of the cookie company Balsen, which is really famous and beloved in Germany. Next, I would like to introduce the faculties and study areas. So the first one I would like to introduce is our Faculty of Engineering Sciences. We offer different study programs in master and bachelor programs, for example, in laser technology, mechanical engineering, and electrical engineering. The next one is Applied Computer Sciences and Biosciences, where we offer 2 study programs completely in English, which is Applied Mathematics and Bachelor and Master program. But also we have like Digital Forensics or IT Security and Cybersecurity. Excuse me. The next faculty is Industrial Engineering, where we, for example, have like business management and business administration and industrial management in bachelor and master. And one of our biggest faculties is the Faculty of Media Sciences. We have media technologies and media management and lots of more. The next faculty I would like to introduce is the Faculty of Social Sciences, where we offer the study program Social Work in a bachelor and a master program. Lastly, I would like to introduce the Institute EVD, and it does not offer a study program anymore, but therefore several modules which are really popular at our international students because they are offered in English. A few more words to our international profile. So we have actually 140 partners in 53 countries all over the world. For example, in Africa, we have partners in 4 countries, and these are 8 partners. In Europe, we have by far the most partners in 28 countries, and a few spread all over the continents of Asia and America. That's from my side. Thank you very much.
So thank you, Annabelle. So not to waste time, let's get into the reason why we are here today, so the STEM contest. Paula Garcia-Llamas from the Universidad de León will give us a brief insight into the working process of our participants till now and what today's final will look like. So please, Paula, the stage is yours.
Well, first, thank you to all of you. It's a pleasure to see you, all of you here, especially the students after so many emails asking for information and co-working. So, first of all, I would like to mention that this contest has the result of the objective of promote STEM vocations, transversal skills among our students, and also to reinforce the cooperation with business and companies. And today, after so many work, we are here and it became true. But also I would like to thank all the partners, and especially you, Stephanie, for being willing to host this event here at the University of Applied Science of Mittweida, and especially also to my colleagues at the University of León, who are not here, but they are part of this event. But I would like to say that today, the protagonists are the students, are the teams, and especially I would like to thank all the mentors, because I know that sometimes it is difficult to be willing to participate in this kind of activities because we are all full of work. But this is possible also thanks to you and thanks to support all of our students. And also at the end, I would like to thank all of our companies who decide to participate and cooperate with EURECA-PRO, also proposing challenges, but also to proposing and be willing to receive students during the internships. So thank you to all of you, and good luck.
Okay, so thank you, Paula, for this overview. Dear participants, could you also please share with us what taking part in the STEM Innovation Contest was for you? So I would like to ask Claudia from the Salesian University of Technology to come here and tell her views.
Thank you. Hello, as you could hear, my name is Claudia. I'm team leader of New Cycle, a team from Salesian University of Technology. We want to thank organizers for the opportunity to be here today and take part in STEM Innovation Contest. We all agree that we developed a lot of skills, both soft skills like teamwork, time management, and focusing on the project, and technical skills, because we really tried to become specialists in our projects. I want to also encourage students, my colleagues from EURECA-PRO Alliance, to take part in future editions of the contest, because it's a really nice adventure and we had a lot of fun because we became friends. Thank you.
Yes, so thank you for your insights. And now we have also a mentor here who would like to add his personal point of view. So, Javier, please go ahead.
Thank you very much. It is a pleasure for me to hear Claudia talking in that way of this contest. It is the first time, and I hope it is not the last, in which this contest must take place. For me, as a professor, it has been wonderful to see students grow, not just with the knowledge they have in their classes, but also doing real technology, real mathematics, real STEM. And that's why all the enterprises have worked, giving some ideas for us to develop really challenging projects that are the most important part of the things that we are doing here today. For that, I have to congratulate the organizers, the students, and also everybody in the EURECA-PRO contest and project, which is one of the main reasons we are here, because it is an open university, an open European university who become reality things like that. Because of that, I think that the real protagonists are the students, so let the contest begin.
Okay, thank you, Javier. It was lovely hearing from you. Of course, we will also select the winner at the end of the day. So on my right-hand side, you can already catch a glimpse on the awards for the participants. In addition to that, the best team will be rewarded with a co-financed internship in one of the European partner countries. And who is gonna be the winner will be decided by our experts, consisting of scientists from the EURECA-PRO partnered universities. So now, I would like to ask the first team, Ingenium Legionensis from the Universidad de León, to come forward.
Good afternoon. It's a pleasure to be here today. Throughout this representation, we would like to invite you to know our new concept of transport. So, get on this bus, get comfortable, fasten your seatbelts, and enjoy this brief trip. First of all, let's present the staff that will make this journey an unforgettable one. We are Ingenium Legionensis. We come from León, Spain, and our names are Alberto, Rubén, Arturo, and me, Andrea. We are a very multidisciplinary group, compounded by engineers from different disciplines such as electrical, electronics, and aerospace engineering. But why a new concept of transport? Is it really necessary? As the proposed challenge states, despite many improvements have been made, there are two main problems in our public transport system. First of all, it is not efficient at all. And second, there is still lack of control. Surely, many of you can see ghost line buses that seems to transport air instead of people, and others that are so crowded that it's difficult to arrive on time. And what about pollution? This is completely inefficient. However, with some changes, we can be environmentally friendly, provide economic benefits, and meet consumers' needs. Here is where our journey begins. First step, the main objective of this project, that is, to monitor in real time the flow of people using a public transport, to improve its efficiency. This will be a benefit for both the customer and the company, not to mention the environment, as we will optimize the use of resources on each line. This improved operation will act as an attraction for potential customers that wouldn't otherwise use this public transport. As we wanted a functional prototype, we framed the project in terms of bus transport. So to achieve this goal, we have used a combined camera and RFID system to process the entry and exit of people from a public transport with the items they are carrying, as bags, backpacks, or suitcases. At this point, you can ask yourself, how can we achieve complete control with just 2 objects? Well, I will try to explain you this with a story in which all of you are the main characters. Try to imagine yourself getting on the bus with the card in your hand ready to be detected by the RFID system. While all of this is happening, a camera is processing your entrance, taking a video, which through a neural network will detect both you and the objects you are carrying. All this data is then sent to a database, thanks to a router, where information is collected and then processed in order to display useful information for other users. We have just arrived to the RFID stop. Sorry. And don't worry, no personal information is stored on these cards. They are only associated with an identification number. During registration process, your personal information is stored on a database from which is not extracted, and we keep privacy protocols to preserve your data. Therefore, when you swipe your card over the RFID, no information about yourself will be exposed on the internet. It will only be used by our system to improve your experience using it. It all starts with the registration of a new subscription. The card is swiped and the data is entered and then is sent to the database. Previously to this, we had to connect the RFID with the ESP. We also created our own reader box. Each time a person gets on the bus, they swipe their card over the RFID, which causes the reader to obtain its numerical identifier, which is sent to the onboard computer via Wi-Fi using an MQTT protocol. All this data is recorded on the database, which together with the cash payments will be used to analyze passenger traffic. Next step, image processing. Probably you're wondering if we can get real useful information from just a simple videos. And the answer is no. But it is not only about the videos. It is also about image processing, from which we can take key information for us. In the bus, there are cameras available at each entrance that start filming once the doors open. Through a neural network, particularly trained for this problem, we are able to detect people getting on and off the bus with the objects they are carrying, as bags, backpacks, and suitcases. In this case, we also take a special care with the privacy of our users, so no videos are shared across the cloud. In fact, they are removed from the system once processed. So the only information we send to the database is the final counting that has been obtained with that processing. For training the neural network, we collected a public dataset in a real environment in order to get enough images to train correctly the network. However, as it was not complete, we generate a scale model in order to get a model that simulates the real environment in which these cameras would operate. So we created our own dataset. Once the videos are recorded, we have to label the different classes that appear on them. By modifying the classes, we can adapt the system to other means of transport. After training the network by adapting the neural weights, we are able to track people and objects passing through the camera. Finally, by means of these cameras, we can achieve a surveillance system due to the possibility of moving them from the onboard computer operated by the driver. This is a very important step, the step of the data processing. With this project, inclusion becomes real. That is that any person with a special need could have at his or her disposal the information they need about the status of the bus, such as the number of people inside or the possibility of being late. In short, it will be the recommendation system itself that would tell the user the route that best fits his or her conditions. Recording the measured data on the database allows us, on the one hand, to monitor the real state of transport system. This information will prove essential for the company to optimize its network. And on the other hand, historical data allow us to create a predictive maintenance in order to prevent potential system failures. To create the recommendation system, there are two flows of information. The first of all, the historical data, and the second, the real-time monitoring. By this way, a user, novel or not, may receive recommendation from our system based on information already stored and the new information provided by itself. Let's see 3 different examples. In this first case, the user is a young woman whose preference is to arrive as soon as possible to her destination. So the algorithm will value more the arrival time. In this second case, the user heads to the airport. So the punctuality is vital for him. Therefore, the algorithm will value more the standard deviation time and the possibility of incidents. Finally, for users with special needs which requires a seat on the bus, the algorithm will value the occupancy on the bus. This is our last stop together, the conclusions. With this project, we are taking a step forward to achieve the concept of smart cities, without forgetting the inclusion of everyone. In other words, moving forward without leaving anyone behind. The implementation of this project, scalable to any means of transport, can lead to benefit for all the parts involved in it. First of all, for the company will not only represent a counting solution. Our proposal, in addition, provides the necessary means to create a greener and more efficient transport system, with a minimum implementation cost. Then, the stored data is used for create the recommendation system that will make a better experience for the users using this public transport, using a robust, low-cost, and sustainable technology. We have proved that our prototype works, and it can be easily adapted to other means of transport and in a larger scale. It's time to go. It has been an honor to accompany you on this journey. However, our bus continues, but always with the doors open to any one of you who want to cross its adventure with us. Now, the question is, do you want to join to the future of transport?
So thank you very much for the presentation. We have a lot of questions, I think, but we would like to start with two so that we have 2 questions per team. And we have to give you points for everything you and your team did, but in one category I'm not so sure. So how have you developed the idea? Who did what in your team?
Thanks for the question. Arturo has developed the recommendation algorithm. Then Alberto and Ruben have developed the RFID system and the hardware of all this technology. And finally, myself, has developed the IA system.
So also, thank you for the presentation from my side. My question is, Google is tracking us everywhere in the world. What is the advantage of this system compared to Google systems?
Hi, thank you for your question. The main difference between Google and our proposal is that we manage in real time and historical data of our transport system. So with that information, we can help the company and the user to improve that transport system. So we have real information and our own information about the transport system.
Thank you.
Thank you for presenting your findings to us. Let's continue with the second team. which is Team New Cycle from the Silesian University of Technology in Gliwice. So please come forward for your presentation.
Concrete, the most widely used construction material. There's no alternative for it. Even the Colosseum is made out of it. It's incredible.
No, I can't listen that anymore. You forgot to mention about how harmful the production of the concrete is for the environment and about its poor properties. Do you really believe it's the best construction material?
All in all, I can see your point. Even recently, I've heard about a new and better construction material than concrete. From what I remember, it's called New Cycle Polymer Concrete.
Good morning. We are a New Cycle team and we are here today to present you the results of our work on Challenge 14, which is
Development of a production method for sustainable structural material using hazardous byproducts, such as byproducts of non-organic chemistry industry.
To understand our project, you need to understand our motivations, you need to understand our why. So, a New Cycle is a group of students that has common mission. We want to take care of the environment using our professional knowledge in field of materials engineering. Your contest inspired us to set a goal. We want to reduce waste emission to the environment and manage waste difficult to reuse. And the idea to execute this goal is to design new technology for the construction material that is solely based on materials that are already in circulation.
Every team needs brilliant mentors. And because of that, we are working with PhD Tomasz Pawlik, ceramics material professor at our department. He has tons of experience with PBL projects. Our second mentor is young and creative Jakub Waste Materials Smoleń. And as you could hear, his main interest concentrates in the field of utilization and recycling of the materials. I need to mention that he once was a contractor in the InSibir project, production of light waste materials, eco-expanded clay.
Now it's time for mentees, because I finally want to introduce ourselves. So my name is Klaudia, I am team leader of New Cycle. I share the power with Kaja Orzechowska, which is a team co-leader. Our male part of the team are Aleksander and Krzysztof. Aleksander is specialized in composite materials, and Krzysztof is our specialist in testing of the materials. And based on our skills, our experience, we decided to distribute the task between us and named our team roles. So I want to emphasize here that we did everything together, but every task had its owner. And for example, Kaja was responsible for creating our knowledge base.
And as it's a challenge, so we wanted to solve the problem. Our first problem is waste automotive laminated glass. This glass is composed of two layers of glass with the PVB foil in between. And this glass has many advantages. It protects our life in the case of accident. But what's happening with the waste windshields, and why 3,000 tons are landfilled only in Poland? The answer is quite simple. During melting of the PVB foil, porosity arises. And in the glass making process, it's really inconvenient because it weakens mechanical properties of the final product. And as a result, glassworks do not want to accept this waste. And consequently, many thousands of tons are landfilled without any idea of development. To this day, two main ways to deal with this waste are known, but neither is perfect. First is mechanical decomposition. It's basically the milling of the glass. It's really cheap and quick, but not effective. Because after the milling, The contaminated glass and not contaminated are separated and again landfilled. The second one is chemical decomposition. As you could hear, that's chemical complex process. So it takes a long time and a lot of money, but it's efficient.
But our research on waste glass didn't stop here, and we discovered second form of glass that is also problematic. There are glass fiber reinforced polymers. It's a kind of material that we can call composite. It has polymer matrix like resin, and it's reinforced with, of course, glass. And now let's look at the numbers. Just in 2020, 6.2 billion tons of fiber-reinforced polymers were produced, and 95 to 98% of this number are exactly glass fiber-reinforced polymers. What is dramatic is the fact that items that are produced out of these materials lives usually like 15 to 20 years, and after that time they will come back to us as wastes because just 13% of them are recycled. And again, we have some available solutions, but some of them I wouldn't even call like that. First of all, going from the top to the bottom of the slide, you can see that the good of the environment of the method is rising, but in the same time, the popularity is decreasing. First method is waste disposal, but you will hear in a minute that it's not really a solution. Then we have some things like combustion and recovery. They are not so good for environment, and they are also expensive. So we decided to look for some solutions in the bottom of the slide when we have some kinds of recycling, like downcycling and upcycling.
Claudia mentioned that waste disposal is the most popular method. But why should we consider this wrong? The answer is it brings many negative consequences for future generations. And also by landfilling the waste materials, we are reducing the amount of the raw materials, so the production costs are increasing. And moreover, we overload the environment and we waste a lot of usable land.
As you could hear, the problem is serious, but don't worry, we are here today with ready-to-go solution. We want to offer you reintroduction of waste glass into material flow circle as fillers in polymer concrete. Polymer concrete is a type of concrete where cement is replaced with polymer. In our case, we replaced cement with polyester resin that was made of recycled PET, like recycled bottles. Every concrete has also fine fraction and coarse fraction. In our case, we decided to make this fraction out of laminated glass. And we used the GFRP as a kind of reinforcement because we also made fillers out of them.
We replaced cement with resin. Why? Production of cement means huge amounts of carbon dioxide that are produced in the atmosphere. In the production of resin, it's zero. Moreover, the cement is characterized as a material with really high water permeability. It's not corrosion resistant, and also it has a really poor toughness. On the other hand, we have resin. This material is durable, it's corrosion resistant, and it has a really low water permeability.
So now I want to invite you to a small trip on our laboratory factory. We also wanted to today show you the technology live, but we should plug somewhere the scale, and we don't have opportunity to do that. But if anybody is interested, we can do this after contest. So the first stage of production polymer concrete is production of the fillers. As you could hear, we had laminated glass. We got it in a form that you can see on the first photo, and it was for us satisfying to have it as a coarse fraction, but we needed to grind it in order to also obtain the fine fraction. GFRP were firstly cut into the cubes, and after that they also could be gridded. And they, after the process, they looked like on the third photo, so they were kind of like fibers. Then we prepared the molds. Some of molds were just ordered, and you can see such a mold on the third photo, and the preparation was just about waxing that. And some of the molds that we needed for our specimens were 3D printed and designed by us, and they were just filled with silicone. Silicone were cured, and you can see the results of that on second photo. And the final stage is mixing and curing the composition. So we put all of our ingredients together, resin, laminated glass, and GFRP. We mixed that, we just filled molds with the mass, and after a curing, we had ready-to-go polymer concrete.
We wanted to create a sustainable solution. As I previously said, the two ways to deal with this waste are known. That's mechanical and chemical decomposition. And here we are with new cycle method. Our method is, first, cheap. We are using waste materials. Second, it's quick. The time of the production is about 1 day, but we are prepared to do this in even 15 minutes. The last but not least, our method of production is really effective because we are not separating contaminated and not contaminated wastes. We are using both of them.
And our method of dealing with GFRP could be named as downcycling. So we are on the bottom of the slide. It's a sustainable method. We just manufacture items that has lower value than in previous life cycle, but it's still a method of recycling.
During preparation to this contest, we've read many articles, but the most helpful was one done by our mentor. Because of that, we decided to keep the same ratio between coarse and fine fraction of the glass. We only manipulated the amount of GFRP. So we have series A with 0%, B series with the 1%, and C with 2% of this composite. And because of that, we obtain and adjust the perfect amount of the resin. When we had our samples ready, we provided 3 main material tests, which are compression test, 3-point bending test, and Archimedes method to calculate open porosity. Now you can see the results of the compression test. Pink represents our new cycle polymer concrete, and gray represents the traditional concrete. As you can see, our samples are showing 3 to 6 times better compression strength than traditional concrete. Even the samples with addition of GFRP obtain better compression strength than samples without. I also need to mention that for all our series, we made 3 samples and calculated the average. Next, here you can see the results of 3-point bending test. And again, gray one represents the traditional concrete. Here, again, you can see that our results are just outstanding. We obtain approximately the same flexural strength at the level of 20 megapascals, while the traditional concrete has like 5 megapascals. So we obtain 4 times better flexural strength. Last but not least, like cherry on the top, it's Archimedes method and possible frost resistance. You know, when it's raining, the water is going inside the holes in the materials, the spores. And when it's snowing and freezing, the material is just destroyed. Here we wanted to create the material that has possibly 0% of the open porosity to be frost resistant. And we succeeded, of course. We obtained the material that has about 1% of open porosity, while the traditional concrete has 16%. Now you can see all of our values all together, but I also need to say about time production of our new cycle polymer concrete. For the traditional concrete, it takes about 1 month, while our concrete can be done in 1 day, or even 15 minutes.
And there is no point to do something that has no applications. So we expect that our polymer concrete will behave like classic polymer concrete. And polymer concretes are used for concrete structures reparation. As you can see on the first photo, the road before reparation and after putting polymer concrete. And I found a map of Katowice, the city that we are from, where citizens can highlight concrete structures that are destroyed. So as you can see, we have a lot of potential work to do just in our city. And also we tried some applications in our laboratory, so we decided to manufacture some pots because, as Kaja mentioned, we expect better frost resistance. And this property is especially valuable in outdoor applications. So sometimes there are problems with fracturing and cracking of pots when they are outside during the winter. And you can take one of the pots with you to your home if you want. There are also butterfly-friendly seeds inside, so you can plant them, but we want to ask you to send us photo where it grows, when it will grow, to show us how it presents in our pots. And to sum up everything, we did it. We faced challenge 14 because we designed technology for production construction material that is based on non-organic chemistry wastes.
Even though our material is almost completely made out of wastes, it's showing so much better mechanical properties than traditional concrete. So we succeeded. We made materials out of waste, and it's better.
And also, STEM Innovation Contest was really great adventure, but we still see a lot of potential work to do with the project. We want to check out new compositions, and we want to write some papers. So we encourage you to just follow up, to be up to date with our projects. Thank you very much for the opportunity to attend here today.
Yes, thank you very much for this very interesting presentation. And I wonder if your new developed processing products are easy to implement in industrial applications. What do you think about that?
Thank you for this question. When we are thinking about this challenge, we had in our heads that we want to create an easy-to-implement solution. And as I said, production of our concrete can even take 15 minutes, but the perfect is 1 day. And only what we need to implement this to the mass production is bigger machines than our laboratory equipment to mill everything and to into the space, of course, for the resin to cure. So we only need bigger machines that big factories have. So that's everything.
Thank you for the presentation. Also, one quick question from my side. You said that recycled concrete is cheap, but is it really cheaper than normal concrete today?
Okay, per ton it's not exactly that cheap as normal concrete, but you don't need to use that much for the same thing to do. For example, we have higher parameters, so we can do thinner and lighter things.
Okay, so thank you for your presentation. And now Our third final team, the Innovative Engineers team from the University of Petroșani, comes to the stage. Applause.
Good afternoon, everybody. My name is Popescu Alexandra Ștefania from University of Petroșani, innovative engineering team. We are glad to be here and to honor with our presence, participating and presenting the project we had made for Eureka Innovation STEM Contest. Yes. In our challenge in the first round, given by Watersoft company to develop any system or tool to improve the recovering, recycling, and reuse of plastic municipal waste. To solve the problem, we have identified most everywhere around the planet and came up with the solution following by what it is wasted. First of them all, I think it's working, I don't know. First of them all, we have made the process for reusing the plastic bottle that pollutes the river and aquatic of flora and fauna. You can see in the video the process of cutting through the hot wire cuts the bottom of the bottles. Bottles enter into process mechanical of hot wires to extract plastic rope out of them. The process flows practically infinite by hot welding them, making a line rope of plastic. As you can see, it goes through the hot wires and connect them, making a really long wire. We tried to give a purpose to our studies, and we developed two ways of use. One is reinforced construction materials with the plastic line rope, and the second one is to build protection cover for solarium against hailstorm. We made layer by layer from plastic rope with hot weld to reinforce gypsum bricks. In hot welding was put in 3 layers to increase strength for mechanical test. The reinforced brick had the similar structure as a simple one. Mechanical power press test was produced to the both testing bricks. For mechanical power press of bending, that it was 700 kilograms, and the mechanical strength for compression was 7 tons. It is obviously that the unreinforced brick broke in half, and the reinforced brick cracked without the structure being damaged. Therefore, we think about it also for solarium that in rains and further the nature destroys them. We try to figure it out also to do better things to work, to be much easier. We created a solarium protection made out of the plastic rope from the cutting process, which will protect solarium against having the purpose of impact strength, it was testing with a heavy iron ball. As you can see, through the bricks, we have made it and resisting. We have a conclusion that in our studies, it was to develop new technology, new product of reusing municipal waste to construct new materials that can be useful for the entire society of the planet. Our team managed to keep up the challenge, give it by water serve company, also develop new construction material that can be reintegrated in circular economy. And we are thanking you so much.
So thank you very much for the presentation. We have some questions, of course, for you, like we had them before for the other teams. The first thing is, you are here now, you are presenting. Who were the members of your team and who had which responsibilities? How did you work together?
Thank you for the question. I know other teams show it before in videos, and for us was not so, a little bit mystery. I'm the leader of our team, and my entire team is composed from my co-leader, Mark Bogdan and Teodora Mitica, with our co-mentor, Itu Razvan Bogdan. Okay, thank you.
And how have you worked together? Because you are from different faculties or from different STEM fields. So were there some challenges for your team, or everything worked fine?
Yeah. Everything was really fine, actually. We work together, we cooperate together, we came up with ideas, and most of all, we help each other. That's the point. We listen to what ideas we had to do it, and we put it in practical. We saw it if it's going to work or not going to work. We're still doing theoretical and practical. Okay, thank you for the question.
And also one of the jury members had the question about the degree of innovation. What would you say if somebody would say, yeah, it's a good idea, but is it really innovative? What would you answer?
You say on the question degree as Celsius or?
No, the amount of innovation. Is it a real innovation in your eyes?
Yes, it is really innovation. Actually, it helps a lot, especially for solarium, that when it rains, especially with hails, the plastic folium can break. So you have to buy a new one. But actually, the entire line of plastic and the testing with iron, to say it helps for the grid to hold it the hell. It doesn't break. It helps and keeps the solarium intact. That's our idea, to help everybody. And to recycling and the plastic that they are in oceans, in flora and fauna. Thank you for the question.
Thank you very much.
So thank you also for the presentation of your results. These were 3 exciting, educative, and very different presentations. For the evaluation, the jury now needs some time for deliberation. There will be a short break now. For the viewers of our stream, please also use this time to get yourself a snack. We will meet again here at 3 p.m. for the award ceremony. Thank you. So welcome back to today's final of the STEM Innovation Contest. So the teams have already presented their results and the jury has done deliberating. And there is a winner. So Volker Tolkmit, The Vice Rector for Education at Mittweida University of Applied Sciences, will tell us more about the outcome. So, Professor Talkmit, please come forward to us.
So, thank you and welcome. Without any second delay, I think that's what you expect from Germany. Welcome to all our guests, students, professors, teachers, researchers of our EURECA Alliance at the University of Applied Sciences Mittweida. It's a great pleasure to have you all here. I would like to give you a warm welcome on behalf of our university board and especially of our rector, on behalf of our rector, Professor Hilmer. My name is Volker Tolkmet. I'm Vice Rector for Education here in Mittweida. Hopefully as you already know in between, we are a university with short paths and quick decisions, very fast decisions, with committed colleagues, of course, and researchers. Sustainability, climate change, renewable energies, innovative environmental technologies, and topics that are anchored in many areas of our university. These topics will have an even greater impact for our teaching and research in the future. Therefore, we are really proud to have you all here and to be the host for such an impressive contest. Traditionally, we are also strong in technical and engineering studies. More than half of our students are enrolled in natural sciences, technique, engineering, and mathematics. Furthermore, as a University of Applied Sciences, we have many cooperations with companies in our region and across Germany. One reason more to be host for this contest, for the STEM contest. Long story short, it's a big honor to be the host for the STEM contest. The EURECA Alliance of our universities is a pioneer for future international studying. I'm convinced we will create joint studies as soon as possible, and we will belong to the first European universities to offer a so-called European degree. The 7 partner universities work intensely together on this goal. The STEM contest is an important milestone on our journey. We saw inspiring ideas and motivated teams in this competition. The teams researched in completely different areas and branches, always with a strong and precise focus on sustainability in production and consumption. So, finally, the challenges confirm that the idea of sustainable production and consumption in our alliance, in our EURECA Alliance, is highly innovative and, above all, alive. Therefore, it's finally my pleasure to celebrate the winners of this challenge and the contest final here in Mittweida. The jury voted within the last few minutes, and I bet it was a difficult decision, I suppose. And I know, of course, in between. Of course, we can declare every participant as a winner, but we want to finally honor your extraordinary activities and the best ideas with a prize. So, together with my colleague, Dr. Stefanie Walter, thank you, I will honor the team that was able to convince the jury the most. And of course, I will start with the 3rd place. We need a break, I believe. We are a media university too, so. 3rd place. The jury presented me. The team would have had more time in their presentation to use the time to convince the jury of the project. There would be space for more content, but the jury realized that it was a very practical and simple solution. Therefore, we celebrate the innovative engineers from the University of Bretošany on the 3rd place. Congratulations. Please come, your stage. Congratulations. Excuse me, let's hold a short distance because we have a small problem with the pandemic situation, so I don't want to risk anything.
We have certificates for everybody?
Certificates for everybody, of course. So, but without the names?
Yeah.
Within the names, okay. Then it is more difficult for me. Congratulations, and once again, welcome to our university. Nice to have you here. So, Bogdan, it's which one? Yeah, Mark. Yeah. Thank you. So, Theodora and Alexandra, Stefania should be you. So, it's my pleasure to give you the prize. So I suppose if I call the name for the 2nd place, it's quite clear who is the winner. But to hold a little bit on, the jury is convinced that the 2nd place team worked in a multidisciplinary area and presented a very impressive prototype with the work, with the presentation. And the 2nd place goes to Spain, University of Leon, and the team is Ingenium Legionensis. Congratulations. Congratulations to the 2nd place. Thank you.
I need a picture as well.
Thank you. Of course, it's quite clear who is the winner, but I think a few remarks should be possible. The winners from the Silesian University of Technology convinced the jury with the environmental benefit in comparison to normal concrete, and especially with the test of the production procedure. Okay, congratulations, very impressive. Please come on. examiner? Okay. We want to get
Together.
together, of course. Congratulations, very impressive.
Thank you very much. Thank you.
And please come on forward.
So thank you for this. We would like to take this opportunity to thank all those who made this competition possible and supported us in its realization. Many thanks to the media faculty of the University of Mittweida, of the University of Applied Sciences, and our students. We would also like to thank those who devised the STEM contest and the staff of the Universidad de León. A special thanks goes to the mentors who actively supported their teams. And last but not least, a big thank to our judges for choosing the winners. And of course, congratulations to the winners of the first STEM Innovation Contest and all the other participants. You all did extraordinarily well. Thank you.